All right, so let's do the review for quadratic functions test. Um, Number one, so the parent function, right? Y is going to be equal to x squared. So we're squaring whatever the x's are. So this would be -3 squared, right? So this would be 9. 2 squared is 4. Ooh, -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Right, 149. These numbers should be very familiar to us. We're just plotting these points, right? 0, 0. 1, 1. 2, 4. And then 3, 9. 149. Right, this is the pattern that it makes, right? 1, 4, 9. Connect the dots. All right. The standard form of the quadratic function y equals a x squared plus bx plus c. That's standard. Vertex form, y equals a x minus h squared plus k. Intercept form, y equals a x minus p x minus q. So these are the three general forms, right? Now, depending on the actual function, then the letters are going to obviously be different. So, for instance, looking at number 5, this is definitely vertex form, right? Because there's the x and then the square. So, what's it saying? So, the form that it's in, I guess. So, it's in vertex form. Right, the x value of the vertex is -4, right? It's the opposite, -4. And the y value of the vertex is 0, right? Because there's no k value, so it's plus 0. So -4, 0. -4, 0. All right, answering some questions about the details, right? We know that the axis of symmetry goes through the vertex. So this is going to be x equals -4. All right, it opens downward because there's a negative in front of the parentheses, right? The a value is negative. The a value, right? The dilation part, the a value is negative, so it opens downward. Not only that, but the dilation is -1. The a value is -1. So it's not stretched or shrinked. It's just reflected. All right, and then lastly, the y-intercept. We want to plug in x equals 0. So when x is 0, we'll get a y value. So here we have y equals -0 plus 4 squared. So again, we're plugging in 0 into x. So this is going to be 0 plus 4 is 4. So 4 squared is 16. So y is equal to negative 16. All right, that's not even on the chart. All right, so graphing this, right? So keeping the formula in mind, the dilation is -1. So we know it's going to open down. So hopefully you've all caught on to the pattern, or if you remember the pattern from previous lessons or homeworks. So since I'm going left or right of the axis of symmetry, when you go out to the next line, right, one line, you're going to do 1 times a. A is -1. So 1 times -1 is -1. So I go down 1. I'm going over 2 lines. Right, somewhere on this second line needs to be a dot. Well, I'm going to multiply a times 4, and that'll give us how many units I need to go down from the vertex, right? So -1 times 4 is -4. So I got to go down 4. All right, since I'm going out 3 lines, then I'm going to go 9 times a. A is -1, right? A is -1 in all of these. -1 times 9 gives me -9, right? So that's here. So all these points will connect. Now, once you find one side, because of symmetry reasons, these points will get reflected across the axis of symmetry. And then we just connect the dots. And there it is. All right, number 6. Again, y equals 2 times x minus 3 squared minus 1. This is definitely vertex form. And the vertex is at +3, -1. So +3, -1. And that vertex is on the axis of symmetry. So axis of symmetry is going to be x equals 3. All right, so because the a value is 2, +2, it's going to open up. And the dilation is the a value, which is +2. All right, y-intercept, we're going to plug in x equals 0 to figure out what the y is. So y is equal to 2 times 0 minus 3 squared minus 1. So 0 minus 3 is -3. -3 squared is 9. So 2 times 9 minus 1. 18 minus 1 is 17. So 17. Okay. Let's get it. So this is going to be, so now we have our axis of symmetry on our vertex. So again, if I go over one line from the axis of symmetry, I'm going to multiply 1, right? That's the first line. So 1 times whatever the a value is. A is equal to 2, right? So 1 times 2, that's how much we go up. So we go up 2. Since I go over 2 lines from the axis of symmetry, I'm going to do 4 times a. So 4 times a, 4 times 2 is 8. So that's how much I'm going to go up. I'm going to go up 8. And then lastly, since I'm going over 3, this would be 9. 9 times a, in this case 2, which would be 18. And that's way off the charts. So I'm not too worried about that one. So both of these points are going to get connected. And these points get reflected across the axis of symmetry. Okay. That's it for number 6. There it is. Okay, number 7. So this one definitely looks different. There's 2 x's. So this is the intercept form. All right, intercept form. And the x-intercepts are opposite inside lies, right? Inside lies. So it's the opposite of whatever's inside. So x equals -3 and x equals +1. Right, because that's the opposite sign of what's inside. So we know that it's going to cross the x-axis at -3 and at +1. So the graph is definitely going to cross. Also, we know that the axis of symmetry is going to be exactly in the middle. So exactly in the middle is -1. So somewhere on this line is the vertex. Right, this is x equals -1. So the axis of symmetry, x equals -1. So somewhere, we just have to figure out where. So we're going to plug in the axis of symmetry into the intercept form to figure out where the vertex is. So it's going to be -1 plus 3 times -1 minus 1. Well, I'm just plugging it into the original equation. So this is -1 plus 3 is +2. -1 minus 1, -2. And then negative out front. So the vertex, which is actually down here, is going to be +4. So -1, 4. So 4. And it's going to open downward. And the dilation is -1. Right, that's the a value outside. Okay. Y-intercept, we could let x equals 0, or we could use the trick, right? Use the trick. Think about it. We're going one line to the right, and the a value is -1. So we're doing -1 times 1. So we're going down 1. And that's going to get reflected across. Connecting the dots. And it just so happened that that's the y-intercept. Right, the y-intercept is at 3, just from graphing it. Y-intercept is 3. All right, that's the first page. Okay, number 8. Again, 2x values or 2x figures. So this is, again, intercept form. The x-intercepts are x equals -5 and x equals -1. So -5, -1. Now the axis of symmetry is exactly in the middle of the x-intercepts, which in this case is x equals -3. So we have to plug that value in to figure out what the vertex is. The dilation, that's the a value out front. All right, so figuring the vertex, let's plug in y equals -2 times -3 plus 5 times -3 plus 1. So this is going to be -2 times +2 times -2. So 2 times 2 times 2. And then negative times negative is a positive. So it's going to be 8. So -3, comma 8. -3, comma 8. So there's the point. So if you want to start plugging in the points, right, we're going to the right of the axis, 1 line. So we're going to do 1 times a, right? 1, 4, 9. Those are the numbers that we're multiplying. So 1 times a, which is -2. So 1 times -2 is -2. So we're going down 2 from the vertex. So 1, 2. 2 lines over, we're doing 4 times -2, which would be -8. So from the vertex, we're going down 8. And that's exactly where the x-intercept is. Okay, going over 3, we're going to do 9, right? Because it's the third line. 3 squared is 9. So 9 times 2 is 18. From the vertex, we're going down 18. So it's actually going to put it right on the y-axis at the very bottom. That's crazy. So here's what the graph is going to look like. All right, and then this is going to get reflected across. Okay, there it is. So the y-intercept is -10. It has a max, because it opens downward, at 8. All right, it's the y value at y equals 8. And domain is all real numbers. All real numbers, or you could say -infinity to infinity. Typically all real numbers. Okay. The range is going to go from -infinity up to the y component of the vertex, which we said was 8. And it's going to be a bracket. Okay. That was number 8. Number 9. Okay, so x squared x minus, so negative 3x squared minus 12x minus 5. All right, this is definitely standard form. All right, this is standard form. There's no parentheses. Standard form. There's clearly 3 figures, an A, a B, and a C. So A is negative 3, B is negative 12, C is negative 5. All right, the y-intercept is always the C value. So negative 5. That's the y-intercept. So negative 5. I know it crosses. The dilation, right? Remember, this is the A value. So the A value is negative 3. All right. The axis of symmetry is going to go through the x value of the vertex. So how do we find the axis of symmetry? Well, we use this formula, negative b over 2a. This will give us the axis of symmetry and also the x part of the vertex. So negative b, so minus b, and b is negative 12, over 2 times a, negative 3. All right. So there's 3 negatives, right? Negative times negative divided by negative. Our answer is going to be negative for sure. And we have 12 over 6, which in this case is negative 2. So x is equal to negative 2. That means the axis of symmetry goes through x equals negative 2. Also, what we learned is that this y-intercept gets reflected across the x-axis. Or the axis of symmetry, rather, not the x-axis. So it gets reflected across. So we just got to figure out where the vertex is. So we have to plug in the vertex, or the x component of the vertex, to figure out what the y component would be. So we're just plugging in negative 2 for x. So this is going to be, I can do underneath, negative 3, negative 2 squared, minus 12 times negative 2, minus 5. All right, this is going to be negative 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 times negative 2, positive 24, minus 5. So negative 24, or negative 12 plus 24 is negative 12. Negative 12 minus 5 is negative 17. Negative 17. Let's make sure. Double check that. Just doesn't seem right. So negative 12 plus 24 minus 5. Okay, yeah, that's not right. Because it's negative 12 plus 24 is positive 12. Okay, positive 12 minus 5. Oh, that's better. Positive 12 minus 5 is 7. 7. Okay, that's better. 7's going to be up here. Okay. So, figure out the dots, right? Or the next points. If I go over 1, right, I'm going to do 1 times whatever A is. A is negative 3. So 1 times 3 gives me 3. We go 3 down. That's what that's telling us. It gets reflected across. So connecting the dots. We're supposed to cross exactly Okay, vertex we said was at -2, 7. -2, 7. And then I showed you the work. We just plugged in the axis of symmetry in. The range is going to go from -infinity up to 7 with the bracket. It goes up to the y part of the vertex. All right. Number 10. Again, this is in standard form. Right, no parentheses. The A is 1, right, because there's nothing in front of x squared. B is -4. C is 3. So the y-intercept is 3, right? It's always the C value. The dilation is always the A value, so 1. So we can plot right now just the y-intercept. The y-intercept is going to be at 3. Okay, figuring out the axis of symmetry. -b over 2a. So negative b, which is -4, over 2 times a, which is 1. So negative times negative is a positive. 4 over 2, which is 2. Axis of symmetry, x equals 2. All right, x equals 2. 3 can get reflected across. It gets reflected across. Okay. The vertex, we're going to plug in the axis of symmetry. So this is going to be y equals 2 squared minus 4 times 2 plus 3. So 2 squared is 4 minus 2 times 4, which is 8, plus 3. So this is going to be 4 minus 8, which is -4. -4 plus 3, -1. So the vertex is 2, comma, -1. 2, comma, -1. All right. And figuring out the other points on the graph, right? A is 1. So if I go over 1, I go 1 times 1, which is 1. So that's how much I go up, is 1. And then this will get reflected across. So if I go over 3, we're going to have to do 1 times 9. 1 times 9, right? Because A was 1. So 1 times 9 is 9. So I got to go up 9. And that gets reflected across. The axis of symmetry, that is. Okay. So now, plugging all these in, or connecting the dots rather. So just so you know, these little curly lines here, that's not part of the graph. That's just what I use to see how many lines I went over. Okay, that was that. Anything else? Oh, the range. So this one's a minimum. So it starts at the y value of the vertex, so -1 up to infinity. -1 to infinity. It always gets the bracket. All right, number 11. Now we go in reverse. We're starting with the picture, and we need to write the 3 forms. Okay, so the first thing, the most identifiable spot is the vertex. The vertex is at 118. Vertex is at 1,18. So this means y equals a, right? We always have to figure out what a is at some point. X minus whatever the x value of the vertex is, right? Which would be 1 squared. And this makes sense because remember, the parent function starts at 0, 0, and we're shifting to the right one, opposite inside lies, so it's -1, and then we got to shift it up 18, so plus 18. So inside lies, and then outside tells the truth. Okay, so now there's two ways to go about this next part because we still have to figure out what A is. One way is to pick a point, some point that's not the vertex. Like I could pick 4, 0, right? 4, 0, and plug this in for X and Y. I could plug in 0, I could plug in 4, and I could figure out what A is. Or if you remember the hint, like the trick that we use to figure out what the next line is. So right, since I'm going over one line, I'm going over to the right one line. How far did I go down? I went down 2. So 1 times -2. So technically -2 would be the A value just from looking at this, right? If had it been on the first one, it would have been -1. But because the next line goes down 2, the A value is -2. So y equals -2 x minus 1 squared plus 18. So if you don't like the trick, right? Like if you're not grasping what I'm saying, that's okay. Just pick a point that's not the vertex and plug it into X and Y. If you do the math, it'll come out to -2, I assure you. All right, X form. Or x-intercept form. So we're looking at the x-intercepts. There's 2, one at +4 and one at -2. So x equals -2 is an intercept and x equals +4 is an x-intercept. These are all roots or solutions or however you want to look at it. If we turn these into factors, right, because the inside lies, x plus 2, x minus 4. And then we just need the A value, right? The A value doesn't change from form to form. So -2. So y equals -2, x plus 2, x minus 4. It almost seems too easy. For the standard form, we're going to FOIL. You could expand either one of these, right? This one's the most closest one. So if you FOIL this out, you get x times x. So first off, -2 times x, which is x squared. X times -4. X times 2. 2 times 4 is -8. Combining like terms, x squared minus 2x minus 8. And this is -2. The -2 is going to distribute, so final answer, y is equal to -2x squared plus 4x plus 16. Okay. All right, we're halfway. Number 12. Based on the graph, what would be the A value? Okay. So looking at this, looking at the vertex, there's the vertex. I'm going over one line from the vertex. Then I'm going down 1, 2, 3. So that tells me that A is -3. Right? 1 times -3 puts us down. What is the standard form quadratic equation? All right, so we want to write this equation in standard form. So we could either use the vertex form or use the intercept form. Me personally, I like the intercept form, right? The intercept form, it's very highly identifiable, right? X equals 5, or correction, X equals -3, and X equals 1. These are the X intercepts. -3, +1. So the form looks like this. So -3, so that means +3, because inside lies. And X minus 1. Again, it crosses at +1 and the inside lies. And we know that A is -3 from the previous problem. So we can replace A with -3. All right, that's the intercept form. Now we're going to FOIL it out. So x squared minus 1x plus 3x minus 3. And -3 has to be multiplied by all this. Combining like terms, just this middle one is 2x. So now we're going to distribute the -3. So answer, y equals -3x squared minus 6x plus 9, right? The -3 gets multiplied to all that. Okay, here's some concept type questions. If the parabola opens downward, what is true? Well, if it opens downward, that means A is negative. A is smaller than 0. So of our choices, we have not this one, not this one. So both of these are smaller than 0. But A can't be 0, right? If A is 0, well, then the x squared would go away. So it can't be D. It has to be B. A has to be negative for it to open downward. If A is greater than 0, right? A is positive, then the vertex has a maximum point. If A is positive, it opens up. If it opens up, it definitely has a min. So this would be false. It's not true. Number 15. Write the quadratic standard form given the x-intercepts. X equals -4, x equals 7. Assume that the A value is 1. Oh, that's nice. Because this just becomes x plus 4, x minus 7, and then A is 1. That's nice. So I don't even write anything. And this is equal to y. So standard form, we're going to have to expand this out. X times x. X times -7. 4 times x. 4 times 7, -28. Final answer. Y equals x squared minus 3x minus 28. Okay, now on to some factoring. All right, 16. It's a binomial. I'm going to always try to apply a difference of squares to the binomial. So this means x squared minus 81 is a perfect square, I notice. So 9 squared. So my A my b, and it's being minus, so that's how I can. So what I'm applying is, if I can recognize a squared minus b squared, which it's in the form that it's in, this can be rewritten as a minus b, a plus b. It doesn't matter if it's minus or plus, but 1 minus 1 plus. So this is going to be, so this is your a and this is your b. So this can be rewritten as x minus 9, x plus 9. Difference of squares. 17. So, right, this is our a value, our b value, and our c value. We use our little method, a times c, which is 20, right? 1 times 20. And we want to come up with numbers that multiply to make 20. So 1 times 20, 2 times 10, 6, 7, 8. Wait, trying to make 20. So 2 times 10, 3, 4 times 5. That's it. So of these numbers, which one adds up to 9? So this makes 21. This makes 12. 4 and 5 make 9. So once you have the perfect pair, the factors are going to be x plus 4, x plus 5. Those are the factors. Okay, 18. This is pretty much the same kind of problem, right? A, 2, B, 1, C, negative 3. Again, we go straight to our x. Can't factor anything out, no GCF, so we go straight to our next step. So A times C. So A is 2. 2 times negative 3 is negative 6. So we have to two numbers that multiply to make negative 6. So one of them needs to be negative. So 1, negative 6. 2, negative 3. That's pretty much it, right? You could say 1, negative 1, 6, negative 2, and positive 3. These also make negative 6. All right. One of these combinations must add up to the b value, which in this case is positive 1. So what adds up to positive 1? Well, this adds up to negative 5, negative 1, positive 5, positive 1. So negative 2, 3. So this is going to be, factors are x minus 2, x plus 3. And since a is 2, right, it's not 1, right, in number 17, a was 1, and the numbers dropped right in, right, x plus 4, x plus 5. Since a is 1, they dropped right in. Here, a is not 1. A is definitely 2. So you have to divide, you have to remember to divide these numbers by whatever the a value is, and then reduce as much as possible. So this would be minus 1, right, 2 over 2, and then this would be x plus 3 over 2. Okay. $19. All right. So again, can't factor anything out. So let's see, straight to our x. This is 24. 1 time, right? A, B, C. 1 times 24. We want it to add up to negative 10. So multiples of positive 24. So 1 times 24. right? But they need to add up to a negative number. So this is saying that both of these need to be negative. 2 and 12, 3 and 8, 4 and 6. Okay. Which ones add up to negative 10? So nope. Negative 2 and negative 12. Nope. Negative 14. 10, 11. Here we go. Negative 4, negative 6. So this is the perfect combination. So x minus 4, x minus 6. All right. And then there's nothing else that needs to happen. Like, we factored it. A is 1, and we're done. All right. To the back. We're on the last page. Okay. Solve the quadratic by using the slide and divide method. That's what we've been using. Must be written in standard form. Okay. So what this is saying, so basically, look, going back to the previous example, the method we're doing is the slide and divide method. We just haven't called it that. Like, that's the method I'm using. Now, these are the factors, right? These are factors. So for the roots or solutions, inside lies. So we got to take the opposite. So the roots here would be x equals 4 and x equals 6. Those would be the roots. So that's what we're going to do. We're just going to take it one step further. So looking at 20, it's in standard form. It's equal to 0. So the first thing I want to do is always try to factor out the greatest common factor. So they're all even. That's the first thing I see. I'm going to take out, I could take out a 2, but then they would still be, like, technically I'm going to take out a 4. I think 4 is the best, right? 6 won't work because 28 is not divisible by 6. So I'm going to factor out a 4. 12 divided by 4, 28 divided by 4, 24 divided by 4. So this is going to be, so when you factor out a 4, with the thing we're doing, the 4 goes out front. So what's left behind? 12 divided by 4 is 3, x squared minus 7x minus 6. Okay, we need to factor the inside part. So we go to our x. Now remember, it's the AC method, right? Like, or slide and divide, however you want to call it. But a times c is what gets written right here. So this is negative 18, right? 3 times negative 6. The 4 is just out there. Leave the 4 alone. All right, and this needs to add up to the b value, which is negative 7. So multiples of 18, negative 18, that add up to negative 7. So one of them needs to be negative. It's going to be the big one, right? Because 1 times negative 18, this will, when you add it up, it'll give us a negative number. 2 times negative 9, 3 times negative 6. That's it. So of these 3, which ones add up to negative 7? Nope. Yes. Nope. So our factors look like this. So 4. And then it's going to be x plus 2, x minus 9. Now, it's the slide and divide method. So because I multiplied by 3, I have to divide by 3. So we reduce as much as possible. This one doesn't reduce at all. This one does, to 3. 9 divided by 3 is 3. All right, so the roots. Okay, so the factors, 4, x plus 2/3, x minus 3. The solutions are the opposite. X equals negative 2/3, x equals positive 3. Those are definitely the solutions. Okay. Let's try it again. Right. Repetition. Repetition is key. Okay. 6, 33, 36. I feel like a 3. 3 will factor out of all of these. So this is going to be 3. So 2x squared plus 11x plus 12. So go to our x. A times c. This is the slide part. So 24 adds up to 11. 1 and 24. 2 and 12. 3 and 8. Actually, I'm going to stop right there. 3 and 8 works, right? 8, 9, 10, 11. That's what adds up to 11. So you're kind of like, as you're doing this, you want to get better. So the factors are going to be 3, x plus 3, x plus 8. Now comes the divide part. You always got to divide by the number you slid over. So 2. 8 divided by 2 is 4. So the factors, 3, x plus 3 over 2, x plus 4. Therefore, the solutions, the opposite. X minus, or x equals negative 3 over 2, and x equals negative 4. Okay. Keep it going. We're almost there. All right, number 22. For this to work, it has to be in standard form. Everything needs to be on one side. So this needs to move over. So we're going to subtract 14 from both sides. Minus 14. Okay. Can't factor out a GCF, right? 9, 11, 14. Nothing comes out. Okay, so here comes the process. 9 times 14. So you will have a calculator. So 9 times negative 14 is negative 126. And this needs to add up to negative 11. So when you're figuring out the multiples, they're both negative, right? So this means the big one needs to be negative. So you could start off with like 1 and negative 126. Right? That's a really big number. So with your calculator, you can start dividing this by numbers to see if it's divisible, right? So like 2 and negative 63. 3, negative 42. 6 and negative 21. Getting closer. 9 and negative 14. Okay, 9, 10, 11, 12, 13. That's it. So this is the list, right? This is the list that multiplies to make 126. Of this list, do any add up to negative 11? No. 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 So, what does this mean? We're sure, I'm sure that this is the list, right? No other numbers multiply to make one, no whole numbers multiply to make 126, negative 126. And we went through the list. Cannot factor. It's almost kind of nice. You just have to make sure that you have the complete list. Okay. 23. I'm going to minus 8x minus 8x. So we have 0 is equal to 3x squared minus 8x plus 5. Okay, going to our, no GCF can come out. So A times C is 15. Adds up to negative 8. Because this is positive and the negative 8 is negative, both of these have to be negative. So 1 and 15, 2, 3, and 5. That's it. That's the one. That makes negative 8. So x minus 3, x minus 5. Again, because we multiplied, we have to divide by 3 and reduce an impossible. So that becomes a 1. So the factors, x minus 1, x minus 5 over 3. So the solutions, x equals 1, positive opposite, x equals 5/3. Okay. Last two. I'm going to subtract 4. So we have, so this is going to be 6x squared minus 5x minus 4 is equal to 0. And GCF can't come out. There's no GCF, right? This gets multiplied over. So negative 24 adds up to negative 5. Here, the big one's going to be negative. So 1, negative 24. 2, negative 12. 3, negative 8. That's the one. 3 and negative 8. All right, that adds up to negative 5. Okay. X plus 3. X minus 8. Now, because we multiplied by 6, we have to divide by 6. So this is going to be x plus 1/2, x minus 4/3. Those are the factors, and the solutions are opposite. X equals negative 1/2, x equals positive 4/3. Okay, last one. So I'm going to move the 5x to the left. So we have 12x squared plus 5x minus 2 equals 0. Okay, going to our x. Can't factor anything out. The 5's messing everything up. So the 12 is going to get multiplied across. So this is negative 24. All right, we've already seen this list. And we need it to add up to 5. Okay, so now the small one's going to be negative, right? Because we need one of them to be negative, but it's got to add up to a positive number. Negative 1 and 24, negative 2 and 12, negative 3 and 8. Oh, look, it's that one. Negative 3 and 8. Right, that makes negative 24. Simultaneously, it adds up to 5. So we get x minus 3, x plus 8, and we divide because we multiplied by 12. We have to divide everything by 12. So this is going to be x minus 1/4, x plus 4 goes into 8 twice, 3. All right. So factors and solutions are opposite. X equals positive 1/4 and x equals negative 2/3. All right, guys. That's it. I know it went quick. Try to keep the mistakes to a minimum. Good luck. Catch you guys in the next video.